Hi guys, welcome back to my channel. So before we start, please don't forget to hit the subscribe button and the notification bell for more videos. So my channel's name is Teacher Dong. Okay, so before we start as well, I would like to thank those who are supporting and watching my videos. So I do hope that my videos help you a lot. Thank you so much. Alright, so this time we're going to talk about triangle trigonometry. So in this case, before we start with the main lesson, we're going to have first the introduction about triangle trigonometry. So it's really important to know what is this branch of math. And then after that, we're going to talk about the 6 trigonometric functions and trigonometric functions of special angles. Alright, so for my students, you can actually check your reference books. Okay, so our lesson for today is on pages 354 and 360. Let's begin. First, let's define if what is trigonometry. So trigonometry is the branch of mathematics. So same as well with the, it means when we say branch, it's the same as statistics, calculus, algebra, and so on and so forth. Okay, it's a branch of mathematics that deals with relations between the sides and angles of a triangle. So mainly, we're going to talk about the measurements of and relationships of the sides and angles of triangles. So or any type of triangles, but in this first lesson, we're going to talk about right triangles or the 6 trigonometric functions in a right triangle. Alright? So what is the origin of the word trigonometry? It came from the two Greek words trigonon or trigonon meaning triangle, metron meaning to measure. Thus, it literally means measurement of triangles. Alright, so that's the meaning of that's the literal meaning of trigonometry if you will combine the um, two words or the origins of the word trigonometry. Okay, so who is the founder and father? The founder and father of trigonometry, as you can see in the illustration, is Hipparchus of Nicaea. Okay, so we have this branch of math because of Hipparchus. So Hipparchus was a Greek astronomer, not only a mathematician but an astronomer, geographer, and mathematician. So he is considered the founder and father of trigonometry rather, but is most famous for his incidental discovery of precision of the equinoxes. But we will focus on trigonometry. Okay. Now, so he's the one who developed or who combined the different concepts so that he can form the branch of math which is trigonometry. Okay, so I'm just sharing the knowledge which was actually founded by Hipparchus. So I'm just sharing it. So he's actually dead long time ago. Okay, now what are the applications? So for as long as it talks about heights and distances that involves triangle, we are talking about trigonometry. So example, in engineering, of course, we are also dealing with heights and distances. Engineering, architecture, chemistry, physics, and so on and so forth, you can actually see trigonometry. And even in calculus, actually, it's being used. Most specifically, so the 6 trigonometric functions. Alright, so as you can see in the illustration, if you are in a 10th floor building and then you look down, that is already a trigonometry if you will be measuring the line of sight or the distance between your eye and the ground. Okay, so just like in the illustration, because it already forms triangle. So that's it. Okay, for as long as it talks about heights and distances, you can see trigonometry. Okay, next, let's begin with first with the 6 trigonometric ratios. But before that, it's really important to pronounce right the 6 trigonometric functions. Okay? So, we have the sine theta. So, when we say sine theta class, theta is actually the symbol for angle. But for the symbol of angle, you can use the different Greek letters or letters in the Greek alphabet. Like for example, alpha, beta, and so on and so forth. But mostly we are using theta or alpha and beta. There's no problem. You can also use the letters in the English alphabet A to Z, okay, to denote or to represent an angle. Okay, so let's read the following. First, let's have first the primary trigonometric functions. Alright, so let's read them properly. First is sine theta. Sine theta. So I would like you to repeat it. Sine theta. Okay, very good. Next, we have cosine theta. Cosine theta. Repeat. Good. Next, we have tangent theta. Tangent theta. Repeat. Okay, very good. So it's a good thing that you can actually follow with what I'm saying. Okay. So these three are what we call the primary trigonometric functions, and these are the secondary trigonometric functions. When we say secondary, they are actually the reciprocals of the primary. Okay. So for the secondary trigonometric functions, we have the first one, cosecant theta. Everyone, cosecant theta. Very good. Next, we have secant theta. Again, secant theta. Very good. Okay, so you are pronouncing it right. Lastly, we have cotangent or cotangent, or you can use cotangent theta. Everyone, cotangent theta. Okay, so it's a good thing that you can actually pronounce right the six trigonometric functions. Okay, so when we see secondary, actually they are just like what I'm saying a while back, they are actually the reciprocals of the primary trigonometric functions. Okay, so let's say for example, if we have cosecant theta is also equal to 1 over sine theta. So cosecant and sine are related because cosecant theta is the reciprocal of sine theta. So same as well with secant theta. Secant theta is the reciprocal of cosine, so therefore we can say that this one is 1 over cosine theta. And then the third, we have tangent, or rather cotangent theta. So cotangent theta is the reciprocal of tangent theta. So we can actually write it as, or it is equal to 1 over tangent theta. Okay, that's it. Again, the last three functions are what we call the secondary because they are what we call the reciprocals of the primary. Okay? So if you have a question or if you have some clarifications or questions regarding the six trigonometric functions, you can actually comment down, or for my students, you can actually chat me directly so that I can answer them. Okay? Thank you. Now, let's have the six trigonometric ratios. So it's really important to know the six trigonometric ratios. Why? Because these are the things to remember whenever you solve for the specific ratio or function. Okay? So let's say we have the right triangle and the angle is here. The angle, we use the symbol theta for it. Okay? If the angle is located here, so this leg is what we call the opposite leg because it's actually opposite the angle. And then this one is what we call the adjacent leg. By the way, take note, we are talking about right triangle. Okay? So this one is what we call adjacent angle because adjacent leg rather because it is beside the angle. Okay? And of course, in a right triangle, opposite the right angle is always the hypotenuse or the longest side of the right triangle. So in our previous discussions or lessons, we're able to discuss a lot of things about triangles, right? And the different types of triangles as well. Now, okay, what if, teacher, the angle is here? So let's say we use alpha here. Okay, the opposite side is already this one, and then this one will serve as your adjacent. Okay, it depends on the placement of the angle. If where is it, if what are we pertaining for? Okay, so take note of the legs. Okay, so if the angle is here, this will serve as the opposite, and then this is the adjacent. And if the angle is here, okay, so this is the opposite and this is the adjacent. Okay, take note. And now let's have the following primary trigonometric ratios. First, we have sine theta. So to solve for sine theta, you need to divide opposite leg and the hypotenuse. Again, you need to divide opposite leg and the hypotenuse. Okay, so that's the value of sine theta. So you will multiply opposite leg, you will divide opposite leg and adjacent leg. I'm sorry for that. Okay, yeah, that's a mistake. Okay, opposite leg divided by hypotenuse. Remember. Then for cosine theta, you will divide adjacent leg and hypotenuse. Adjacent leg, this is the adjacent leg and the hypotenuse. Then for sine, it is opposite leg and the hypotenuse. Again, opposite leg and the hypotenuse for sine theta. And then for cosine theta, it is adjacent leg and the hypotenuse. Take note. And then lastly, tangent theta, it's opposite leg over the adjacent. This is the opposite leg, this is the adjacent. You will divide them for tangent. So is there a way to easily remember the trigonometric or primary trigonometric ratios? Yes, we can use the acronym SOHCAHTOA. So for sine equals opposite over hypotenuse. Sine theta equals opposite over hypotenuse. So, it's easy to remember. So, S-O-H. Then for cosine theta, you can use ka. Cosine theta equals adjacent over the hypotenuse. As simple as that. Then for TOA, okay, tangent theta. So, tangent theta is equal to opposite over the adjacent. That's why it's TOA. So, it's easy to remember now. Whenever you actually solve for the value of the function, you can actually use the acronym SOHCAHTOA. Okay, SOHCAHTOA. Now, how about for the secondary trigonometric ratios? The secondary trigonometric ratios are actually the reciprocal of the primary. So, if for sine theta, it is opposite over hypotenuse. For cosecant theta now, just actually get the reciprocal. It will now become hypotenuse over opposite leg. Hypotenuse over opposite leg. Okay? So, you will divide hypotenuse and the opposite leg. So, it's the other way around. Hypotenuse over the opposite leg. Then, for secant theta, you will actually divide hypotenuse and the adjacent leg. Hypotenuse and the adjacent leg. Secant theta. Okay? Secant theta, hypotenuse over the adjacent leg. And then for cotangent theta, okay, it's adjacent leg over the opposite leg. Remember, they are just the reciprocals of the primary trigonometric ratios. Okay? Reciprocal. Now, is there also an acronym? Yes, you can use the acronym CHO-SHA-COW. Okay? If you are confused, you can use CHO-SHA-COW. For CHO-SHA-COW, this is for cosecant or the reciprocal of sine. So, it's cosecant equals hypotenuse over the opposite. Then, for secant theta or the reciprocal of cosine theta, it is SHA. So, we have secant theta equals hypotenuse over the adjacent. Then, for cotangent theta, you can use COW, which is the reciprocal of tangent theta. Okay? Cotangent theta equals adjacent over the opposite. As simple as that. Okay? Easy to remember. Again, for primary trigonometric ratios, we can use the acronym SOHCAHTOA to easily remember or recall it. Then for secondary trigonometric ratios, they are just the reciprocal of the reciprocals of the primary. Okay? You can change the places of the numerator and denominator. Okay? That's why they are what we call reciprocals. Okay? Or you can use the acronym CHO-SHA-COW. CHO-SHA-COW. Again, SOHCAHTOA for primary, CHO-SHA-COW for secondary. Take note of this, okay? So for us to apply these 6 trigonometric ratios, let's have the first example. Example 1. Find the values of the 6 trigonometric functions for each of the following indicated angles. Alright, so we have alpha, which is the first angle. We have also beta. Then we have two measurements, 5 and 12, and r is unknown. If that's the case, there in a right triangle, if there are two measurements that are actually there, and then there's only one which is unknown, just like this, the hypotenuse is unknown, you can solve it using the Pythagorean theorem. But if there are two unknown measurements and there's only one given measurement, there's no problem. Do not solve. You cannot use the Pythagorean theorem if that's the case. Just simply get the ratios. Okay, but if in this case there are two measurements that are given, we can solve the third one, which is also the hypotenuse, which is symbolizes by r. Okay, now so we can use the Pythagorean theorem, c square equals a square plus b square. Okay, so wherein c square is your r or the hypotenuse, and then substitute 5 square plus 12 square. Then afterwards, okay, let us simplify this one. 5 square is 25 plus 12 square is 144 equals r square. Then r squared is equal to 25 plus 144, it's 169. Then extract the square root of both sides, okay? Square root of r squared is square root of 169. So therefore, r is equal to positive, negative. What's the square root of 169 based on our previous lessons? It is about radicals. It is 13. Okay, 13. So we take positive 13 because we are talking about measurements of the triangle or leg of a triangle. Okay, so use positive 13. Now we are able to complete now the measurements using the Pythagorean theorem. So we can now solve for the 6 trigonometric ratios in terms of alpha and beta. So for alpha, we will be solving sine alpha, cosine alpha, tangent alpha, cosecant alpha, secant alpha, then we have cotangent alpha. Then in the other side, we're going to have in terms or the angle in terms of beta. We have sine beta, cosine beta, tangent beta, cosecant beta, secant beta, and then we have cotangent beta. Alright? So we're going to solve now. Let's have first the alpha. Okay, the alpha. Okay? So sine alpha. Okay? So remember, for sine, opposite over the hypotenuse. If this is your angle or the alpha, this is the opposite now, and this will serve as your adjacent, and this one is your hypotenuse. So for sine alpha, it is opposite over the hypotenuse, so therefore it is 5 over 13. That's it. Opposite over hypotenuse. Then for cosine alpha, we're going to use ka, adjacent over the hypotenuse. So it is 12 over the hypotenuse, which is 13. Okay, this is your adjacent and this one is your hypotenuse. Then for the tangent, we're going to use the acronym TOA. Okay, opposite over the adjacent. So it is now 5 over 12. 5 over 12. So this one is your opposite and this one is your adjacent, 5 over 12. We're able to have now the primary. Let's have the secondary. Cosecant alpha is the reciprocal of sine alpha. We can just actually get the reciprocal of 5 over 13, which is 13 over 5, or what we call the hypotenuse over the opposite. And then in this case, secant alpha is the reciprocal of cosine alpha. So therefore, get the reciprocal of 12 over 13, which is 13 over 12. So this one is your hypotenuse, this one is your adjacent. Then for cotangent alpha, okay, so get the reciprocal of tangent alpha, 5 over 12, it will become 12 over 5. So this one is your adjacent, this one is your opposite. Okay, adjacent and the opposite. So therefore, we use cho, sha, kao for the secondary. Cho, sha, kao. Then here we use so, ka, towa. Is it clear? Okay, very good. Now let's have the other one, the angle beta. For the angle beta, this will serve as your opposite, which is the 12, and this is your adjacent now. Okay, so for sine beta, let's use so, opposite over the hypotenuse, so therefore this is 12 over 13. Okay, cosine beta, it is ka, adjacent, this is the adjacent now, over the hypotenuse, it is 5 over 13. Then for tangent, pe beta, towa. Okay, towa, opposite over the adjacent, so it is now 12 over 5. And then for the secondary, just get the reciprocal of or use the acronym cho, sha, kao. So 12 over 13 for sine beta. For cosecant beta, it is now 13 over 12. For cosine beta, it is 5 over 13. So for secant beta, it will now become 13 over 5. Then for tangent beta, it is 12 over 5. For cotangent beta, it will now become 5 over 12. As simple as that. So if you are already familiar with the 6 trigonometric functions, it is easy for you now to identify the measurements. Okay? So better understand this one, let's proceed to the second example. So example 2. A leg and the hypotenuse of the right triangle measure 2 centimeters and square root of 5 centimeters respectively. So as you can see in the illustration, the hypotenuse is given, which is square root of 5 centimeters, and the opposite, because this is the angle, so this will serve as your opposite. The opposite leg is 2 centimeters or measures 2 centimeters. Okay? And this one is your adjacent, which measures A. So as you can see, there are two unknown measurements in a right triangle. Therefore, we can use the Pythagorean theorem now in solving for the value of the adjacent leg. Okay? So, we have c squared equals a squared plus b squared, which is the main formula of the Pythagorean theorem. And then c, which is the hypotenuse, is given as square root of 5 square. And then a is unknown, so this will remain as a square plus b, which is 2 square. Okay, then after that, simplify. Okay, but by the way, please, you can use your calculators, no, and you can actually have your extra paper as we go through with this lesson. Okay, now square root of 5 square, what is the answer? Square root of 5 times the square root of 5. If you are using your calculator and you don't know how to solve it manually, you want to verify on your calculator, what's the answer? So square root of 5 times the square root of 5, or square root of 5 square, is simply 5. Very good to those who got it. Now, equals a square. Let's bring down it. And then 2 square, or 2 times 2, is 4. Then, let's now use addition property of equality to combine the similar terms. Similar terms are 5 and 4. So, 5, and then the opposite of 4 is negative 4, equals a square. So, 5 minus 4 is 1. Then, extract the square root of both sides. Square root of a square is square root of 1. Therefore, a is equal to positive negative 1, and then we will be getting positive 1 centimeters. Now we're able to complete now the measurements of the right triangle, so using the Pythagorean theorem in solving for A. Now let's have the 6 trigonometric ratios. So the angle is theta rather, so therefore we can have the following: sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and then lastly we have cotangent theta. Let's start first with sine theta. Sine theta is opposite over the hypotenuse. This one is 2 over square root of 5. Then based on our unit about radicals, if there's a denominator which is a radical, you have to rationalize. So let's rationalize this one by multiplying to the fraction square root of 5 over square root of 5. 2 times square root of 5, they are the similar terms, so we can just put them together. 2 square root of 5, then square root of 5 times square root of 5 is 5. So therefore, this is your sine theta. 2 square root of 5 over 5. Okay? Next, we have cosine theta. Cosine theta is adjacent over the hypotenuse. Your adjacent is 1 over the hypotenuse square root of 5. So we still need to rationalize this one, guys. Okay, so multiply by square root of 5 over square root of 5. So 1 times square root of 5 is square root of 5 over square root of 5 times square root of 5 is 5. So this will now be the value of your cosine theta. So square root of 5 over 5. Alright, so we use the acronym CA. Cosine theta equals adjacent over the hypotenuse. Next, let's have tangent theta. For tangent theta, we're going to use TOA. We're going to use TOA, or opposite over the adjacent. So for the opposite over the adjacent, we're going to have the opposite, of course, which is 2 centimeters over the adjacent, which is 1. So 2 divided by 1 is simply 2. So tangent theta is equal to 2. Now we have cosecant theta. So for cosecant theta, we can use the acronym CHO. So hypotenuse over the opposite, or the reciprocal of sine theta. So reciprocal of sine theta, we had 2 over square root of 5. We can write here it as square root of 5 over 2. So this will serve as the value of your cosecant theta is square root of 5 over 2. Okay, square root of 5 over 2. Next, let's have secant theta. So for secant theta, we can actually get the reciprocal of cosine theta, which is so cosine theta is 1 over square root of 5. So we can have square root of 5 over 1 or simply square root of 5. So secant theta is equal to square root of 5, or you can use the acronym SHA. SHA. Okay? Hypotenuse over the adjacent. Then lastly, cotangent theta, just get the reciprocal of tangent theta, 2 over 1. For tangent theta, here it will become 1 half or 1 over 2. Or you can use the acronym COW, adjacent over the opposite. Okay, so as simple as that. We are able now to solve the 6 trigonometric ratios given that specific problem or this specific problem. Okay, so if you have a question regarding the 6 trigonometric functions or ratios, you can actually comment down below or simply chat me, okay, on my personal networking, social networking sites, okay, most especially to my students. Now let's proceed. Let's have the trigonometric functions of special angles. Okay, so but before we proceed and go ahead with this one, I would like you to be familiar with this table. So when you say special angles, okay, in our previous lessons, we had actually the special triangles 45, 45, 90 and 30, 60, 90. So same as well with this one, as you can see the angles measure 30 degrees, 45 degrees, 60 degrees. Okay, so we have already discussed them. We will just be applying them here. Okay, now, so how are we going to use this table? This is how you will use it, guys. Alright, so let's say, by the way, you can actually use this table prior to actually performing the operations on the trigonometric functions of special angles. So, yes, you heard it right. You will add, subtract, multiply, or divide trigonometric functions of special angles. But first, you have to get the actual value. Alright, so let's say for example, in the problem, you have sine 30 degrees. In the table, get the sine 30 degrees, this one. So the value of sine 30 degrees is 1 half. Or if you are tasked to get cosine 45 degrees, the value of cosine 45 degrees, guys, is this one, which is square root of 2 over 2. Or if you are being asked to get the value of tangent 60 degrees, okay, so tangent 60 degrees is square root of 3. Or so cosecant 45 degrees, okay, cosecant 45 degrees is equal to square root 2. Cosecant 45 degrees is equal to square root of 2. So I think my pen is malfunctioning. Alright, so that's how you're going to use the table. Take note of that, okay? Whatever is the intersection, that's the value. Let's proceed to the following examples. Evaluate the following. Alright, so this is what I'm telling you. We are going to use the table in identifying the values first of the function, and then after that, you can actually perform the indicated operation or operations involved. Okay? Now, for letter A, we are going to subtract sine 30 degrees and tangent 45 degrees, or simply sine 30 degrees minus tangent 45 degrees. How is this one? Okay? So, first is get the values of each. Sine 30 degrees in the table, what is it? Sine 30 degrees is 1 half. Write it. Minus tangent 45 degrees. So, tangent 45 degrees is simply 1. So, we are now ready to solve for it. Okay, if you have your calculator, you can actually compute 1 half minus 1. Or if you would like to solve it manually, get the LCD, which is 2 times 2 divided by 2 is 1 times 1 is 1. 2 times negative 1 is negative 2. Then subtract the numerator. So 1 minus 2 is negative 1 half. So the value of sine 30 degrees minus tangent 45 degrees is negative 1 half. This is now your answer. As simple as that. Okay, so actually, what's the first step? You're going to get the value on the table, or rather in the table, and then after that, perform the indicated operation. Right, letter B, we have tangent 30 degrees and cosine 30 degrees. Okay, so Tangent 30 degrees, you will multiply it to cosine 30 degrees. If you will see, if you are going to encounter this type of example, you need to multiply tangent 30 degrees times cosine 30 degrees. First, get the value of tangent 30 degrees. So, tangent 30 degrees is square root of 3 over 3 in the table. And then cosine 30 degrees, it is square root of 3 over 2. And then, okay, since this is multiplication, just multiply the numerator and denominator. Square root of 3 times square root of 3 is 3. Then 3 times 2 is 6. Okay? 3 over 6, you can still reduce this in its lowest term. 3 over 6, the LCM that we can use here is 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So the final answer is 1/2. Okay? The value now of tangent 30 degrees times cosine 30 degrees is equal to 1/2. Okay, so if you have a question regarding this, comment down below or just simply contact me for my students. Okay? Right, let's proceed to the other two examples. Letter C. How is this, teacher? Cosine square 45 degrees plus sine square 45 degrees. So if that's the case, we're going to add. But as you can see, don't be confused, or this is not difficult. Okay? So cosine square 45 degrees, first is get 45 degrees, cosine 45 degrees. In the table, cosine 45 degrees is square root of 2 over 2. Just put the square outside the parenthesis. Plus, sine 45 degrees is also square root of 2 over 2 square. Okay? Then, the next thing is, we are going to apply quotient law of exponents, distribute the exponent outside the parenthesis. So, square root of 2 square, or square root of 2 times square root of 2 is 2. Then, 2 square or 2 times 2 is 4. Plus, square root of 2 times square root of 2 is 2. Then, 2 times 2 is 4. Then, add. Okay, they are already similar fractions, so therefore, you can add the numerators. 2 plus 2 is 4 over 4. Then, 4 divided by 4 is simply 1. 1 now is your final answer. So, therefore, if you're going to actually add cosine square 45 degrees and sine square 45 degrees, the final answer is 1. Then last example, we have letter D. Sine 60 degrees divided by cosine 60 degrees. So this is division. Sine 60 degrees over cosine 60 degrees. So this is very simple, guys. Okay, so you can actually get the value. What is sine 60 degrees? So sine 60 degrees is square root of 3 over 2, while cosine 60 degrees is 1/2. You can also write this as square root of 3 over 2 divided by 1/2. So the rule for the division of fractions, get the reciprocal of the divisor. Copy the dividend, which is square root of 3 over 2, times the operation now is multiply. The reciprocal of 1/2 is 2 over 1, or simply 2. Then just simply multiply the numerator. Square root of 3 times 2 is 2 square root of 3. Bring down the denominator, which is 2. So since they are the same, you can divide. 2 divided by 2 is 1. So therefore, the final answer is square root of 3. This will serve now as your final answer, square root of 3. Square root of 3. Okay? That's how you perform the operations on the 6 of trigonometric functions of special angles. Okay? First step is you need to get the value in the table, and then after that, perform the indicated operation. As simple as that, guys. Okay? And then for as long as you know the different rules in algebra and fractions, okay, so you can actually do it properly with the guide of your scientific calculator. So in the last example, guys, I would like you to bring out your calculators for your calculator practice. So use a scientific calculator to find the value of the following in 5 decimal places. Okay? Just simply follow the steps, okay? What if they are not special angles and they are like this? So you can actually solve them using your calculators. Alright, so first we have sine. I think we have already encountered this in our previous units. So this is how you're going to read it. So this is degree, minutes, symbol. So let's solve now. Sine 10 degrees, 10 minutes, 10 seconds. Okay, on your calculator, I would like you to follow this instruction. Sine, click on sine, and then some calculators, open parentheses will show up but others will not. Okay? Then enter 10 or 10. Then the DMS symbol, some other calculators it is DMS, but in the Casio calculator the symbol is this DMS. Okay, for the degree, and then enter 10 again or 10 DMS for minutes, and then another 10 or 10, then DMS for seconds, and then don't forget to enter the close parenthesis. Then afterwards, okay, click equal sign. What is your answer? So the answer is supposed to be 0.17656. We need to actually round it off in 5 decimal places or write it in 5 decimal places. If you did not get it, please make sure to try it again. Try and try until you get the right answer. Okay? Now, letter B, cosine 200 degrees. So, there's no problem with this one because we don't have minutes and seconds. Okay? Okay, on your calculators, enter cosine, open parenthesis, then 200, 200, and then the DMS symbol, close parenthesis, equals, or click on equal sign. You have to get 0.93969. So this is the answer that you have to get. Okay, if it is not the answer that you got, please repeat the process. Now, letter C, we have tangent 23.8 degrees. So this is very simple. Tangent, open parenthesis, then 23.8, DMS symbol, close parenthesis. The answer that you have to get is 0.44105. Again, if your answer is not this, please repeat the process on your calculators until you get the right answer. Okay, now let's have the secondary. So we're done with the primary. How about the secondary? So common mistake is they are actually getting they are they are clicking shift and then sign. That's wrong. That's inverse. Okay, this is how you do it. You're going to do it. Cosecant is the reciprocal of sine, right? So if that's the case, we can just actually dial this one on your calculator. How are you going to simplify cosecant negative 21 degrees? So dial 1 divided by sine, open parenthesis, negative 21, DMS symbol, close parenthesis, equal sign. That's how you're going to do it. You're not going to click any shift key or what. Okay, it's 1 divided by sine. It means it's the reciprocal. Okay, so your answer, or the answer that you have to get for letter D, is negative 2.79043. So if your answer is not like this, please make sure to repeat the process again until you get it. Now, letter E, we have secant 32.1. So this one is minutes, not degree. So how are you going to write it? So it's 1, and then secant is the reciprocal of cosine, so therefore it's 1 divided by cosine, open parenthesis. So write 0 for degree because it doesn't have any value, DMS symbol, and then 32.1 for minutes, DMS symbol. You're not going to have any more seconds, okay? Close parenthesis equals, the answer that you have to get here is 1.00004. Again, if this is not your answer, please repeat the process. Now, letter F, we have cotangent 7 seconds. So for cotangent 7 seconds, it's the reciprocal of tangent. So it's now 1 divided by tangent, 1 divided by tangent, open parenthesis, 0, DMS, 0 minutes. Why? Because we don't have a value for degree and minutes, we only have seconds. Finally, you have to write the first 2 before the seconds, okay? It must go in order. Then dial 7, DMS again. Close parenthesis, equal sign. The answer that you have to get is what? It's 29,466.40088. I think it's exact based on what I'm seeing now on my calculator. Okay? So just follow the instruction, just follow the process, okay? Please be familiar on the symbols that we have to use for the functions, okay? So you're going to do this one if in case the angle is not actually a special angle, just like what you are seeing. Alright, so I do hope that you have learned a lot in this specific session. So first, we talk about the 6 trigonometric functions or ratios. Just remember the acronyms. Okay, you will not get wrong answers for that. So SOHCAHTOA for the primary, and then CHOSHACAO for the secondary. Then for the operations on the trigonometric functions of special angles, okay, first is remember to actually consider the table in getting first the values, and then after that, that's the time that you can perform the indicated operations. Okay? Alright, so for my students, please don't forget to actually accomplish this activity. Okay, so this is supposed to be 367 to 368. Okay, so the title 6 trigonometric functions and trigonometric functions of special angles. Okay, then we have page 358 and 367 to 368. Just follow, just consider the things that we have discussed, and then you will be able to answer this activity. Okay, so if you have questions or clarifications, most especially to my students, please make sure to contact me or chat me on my social net sites. Okay, so thank you so much for those who are supporting my vlog. Okay, so for those who are not yet subscribed, please subscribe and hit the notification button, not teacher dong. Okay, so thank you so much and have a nice day ahead. Okay.